U substitution. Let me do some easy examples here. We know that when we have f of some function, a composite function here, f of something times outside happens to be another function, I don't know, let's say it is just the derivative of this with some manipulation, then we said, oh, this is u, and this one, okay, with some manipulation becomes du. Then we can simply write this as f of u du. Okay, then we can evaluate from here. That's the whole idea of u substitution. Okay, let's do some easy examples. E to the, let's say, 2x dx, and I'll show you in a moment the shortcuts. We know that when we have e to the x dx, when xx, this is simply ex plus c. But we got 2x, so that's the inside function, okay, like dx here. Then we let u be 2x, and we take derivative of both sides with respect to x, we get this, and we write in differential form, so du is 2 dx. Then we isolate dx, so du over 2 is dx. So with this integral becomes e raised to, this is u, and dx is now du over 2. We converted this integral in terms of a new variable u. Now this can be done easily because this 2 constant can be pulled outside, e to the u du, and this is just like this, e to the x dx. So 1/2 e to the u plus c, but u was not in the first place, so u is 2x. We go back and back substitute u as 2x. Okay, simple sense than this. This is ex. When we have 2x, since we cannot produce 2x there, we cannot just write answer in one line, so we have to do something. But if you look at closely from here to here, here is 2, that number 2. In the answer, that is just 1/2 here. So how about this? If the question is, what is e raised to 3x dx then? Okay, with some work, it must be 2, so here is 3, so it has to be 1 over 3 e raised to 3x. Okay, we can go through this. That's why for this simple, it's still a composite function, but so simple, we don't have to go through this procedure. So let me give you a general formula here. So when we have e raised to a number, alpha x plus, it can be another number. When we take the derivative of this, just alpha survives, right? This one with respect to x, this will be simply 1 over alpha, and whatever that e alpha x plus beta plus c. Like when we have e raised to, let's say, 5x, this will be 1 over 5 e raised to 5x. Okay, when we have e raised to negative 2x, that will be 1 over this negative 2 e raised to negative 2x. Okay, in the same way, when we have e raised to, let's say, 7x minus 1, this 7, like is alpha, this 7, it will be 1 over 7 e raised to 7x minus 1 plus c. Okay, it can be done. I mean, you don't have to go through this. Similarly, let's look at sine. Okay, when we have sine alpha x plus, let's say, beta dx, then this will be it's a u sub. Okay, if you want to go through everything, then this is your u, and you go through all the steps. But this is so simple. we can just say, oh, antiderivative of sine is negative cosine alpha x plus b beta, and here's a number. We just have to divide, like here we can divide in the front or all over, same thing, minus 1 over this alpha. As long as alpha is not 0, this is the case. Okay, note that this should be only x, not x squared. So if we have, let's say, sine 2x minus 3, that will be then minus, because antiderivative of sine is negative cosine 2x minus 3. But this 2, when we differentiate, we would get times 2, so we need to divide. So that divide means 1/2. Not only for sine, it works for other functions, like let's say secant squared 5x. Okay, antiderivative of secant square is just tangent, and that 5x, oh, there is a 5, we need to divide by 5, or just 1/5 on the front. Okay, in the same way, let's say we have cosine 4x. Oh, antiderivative of cosine is just sine, divide by 4, which is 1/4, plus c. Okay, in the same way, let's say secant 2x tangent 2x. So antiderivative of secant tangent is just secant. We got 2x, and this 2 we divide by 2. Okay, and we know that when we have 1 over x, that's natural log of x plus c. But how about when we have 1 over 2x? Oh, this 2 can be pulled outside, simply outside. Oh, that's on the bottom, not 2. It becomes 1/2. Okay, 2 outside, 1 over x dx. And that is 1/2. And antiderivative of 1 over x is just natural log of x. So though it's 2x, there is a product, so we can pull outside. Okay, and plus c. In the same way, let me expand this. Suppose we have 1 over 2x plus 3 now. Okay, we were supposed to do u sub. Okay, 1, this is our u. Let me show you the long way and I'll show you the shortcut. So let u be 2x plus 3, then du over dx is just 2 dx. So that dx is du over 2. Okay, with this becomes 1 over u, and dx is now du over 2. Okay, du over 2. Now this 2 can be pulled outside, 1/2, 1 over u du. Then this is 1/2 natural log of u. Then 1/2 natural log of u is just 2x plus 3 plus c. And if we look at closely, it's the natural log of bottom. Okay, natural log of bottom, and we simply divide it by 2. But if we use this, let me use this. So if I have 1 over then 3x plus 4, okay, not 3x square, other thing, just 3x plus 4. Using this using this rule, all we have to do is the natural log of bottom, but the derivative of bottom is 3, and we need to divide by that 3, so 1/3 divide by 3, same thing, plus c. Okay, and how about this 1 over 2x dx? Using the same rule, it's a natural log of 2x but derivative of 2x is 2, so we need to divide by 2, which is same as multiply by 1/2. Then wait a minute, what we did earlier, 1 over 2x dx is same as 2 can be pulled outside, 1/2, that leaves 1 over x dx, and that's 1/2, and that's natural log of x plus c. So we got two different functions for the same question. So 1 over 2x dx, so we got different answers. In fact, these two are equivalent because this c is arbitrary constant. If you take the derivative of this, you're going to get 1 over 2x. And also if you take the derivative of this, you're going to get 1 over 2x as well. The idea here is this plus c. These c are not the same c. Okay, this c different constant, the arbitrary constant. So they are taking care of the fact, because this can be, if you look at closely, this one is same as 1/2. Natural log of product is sum of natural logs. So natural log of first, natural log of x, then plus c, but natural log of 2 is a number. This is a number, and 1/2 times number is another number. So I got 1/2 natural log of x plus c plus 1/2 this is a decimal number and a constant. If I start saying, okay, this was c1, okay, let's say this is c1, then this c1 plus this constant, I can simply say c. And if you say in that way, oh, then these two are same answers. These two are same. So 1 over 2x dx, in this case, since we can pull 2 outside, we can go in this way, or we can just write in this way. Unfortunately, when we have 1 over 3x plus 4, we cannot pull 3 outside and leave 1 over x plus 4. That's wrong. All we have to do is this idea. Take the natural log of bottom, okay, and divide it by the derivative of bottom, which is 3. Okay, and see my website for more examples.